Hi, this is Dan Jacob with PTC Windshield Quality Solutions, and I'm here to introduce our topic for today's discussion, exploring the impact of the latest DoD directives on reliability. I'm joined by Lowell Nilsson from BAE Systems Land and Armament, and we'll have a presentation as a part of this here in a moment. Our agenda for today is to discuss changes to DoD directives on reliability. Then Lowell will discuss BAE's approach to reliability. We'll then discuss PTC's solution, windshield quality management, and then talk a bit about windshield quality solutions. First, on the topic of recent initiatives in the DoD, there's for years it's been known that there's consequences of not managing quality, and you can see on the graph on the left side different aspects of this where it can result in program cancellation, launch delay, field failure and repairs, and costs, etc. On the right side, you see the a memo which was released in June 30th of last year, titled State of Reliability. It was released by Dr. Michael Gilmore, who's the Director of Operational Test and Evaluation. And there's a number of highlights in this, including statements on in his memo that discuss that poor reliability is a problem with major implications for cost. He reaffirmed that the merits of the reliability standard ANSI-GIA 0009, and so on. And there's a number of other items in here as well, including the fact that your poor reliability and inability to complete assigned mission significantly impact costs. The high sustainment costs are required to maintain and support unreliable systems, and then improving system reliability early during system design and development reduces sustainment costs. And you can see the actual excerpts of the quotes from the memo on the right-hand side there. Some of the key quotes are listed below, which indicate that over the 25 years of DOT&E's existence, only about 75% of defense systems are found to be suitable in operational testing. And in 2007, 4 of the 8 were not found suitable. In 2008, 2 out of 6. And so on. So there's a common trend where there's programs that are not meeting reliability requirements, and this memo categorized some of the issues that were concerns of the DoD. Other items that have been that were referenced in that memo, but have also been released recently, have made a number of changes the way that DoD sees reliability and reliability's impact on cost. One of the key changes in the last few years is the adoption of ANSI-GIA 0007 and 0009. 0009 particularly is focused on it makes a number of changes to older standards such as MIL Standard 785, and it goes beyond MIL Standard 785 by incorporating system engineering processes and requiring systematic processes to identify and mitigate failure modes throughout the product lifecycle. It requires the incorporation of customer needs into a reliability program plan and verification that those needs are being met throughout the product development process and prior to fielding the product. It monitors fielded product performance and identifies a need to communicate corrective actions and track reliability growth. There was the Product Support Manager Guide, which was released in 2011. This is from the Defense Acquisition Guide. Identifies where earlier focus on sustainment in the product lifecycle, the need to manage reliability, availability, and sustainability throughout the lifecycle of the product, integrating acquisition and sustainment phases, and the need for design for reliability activities, reduce the logistics footprint, and affordable support, which is a trade-off, but it's something that's being identified as a clear requirement from the Product Support Manager Guide. DTM 11003 was just released in early 2011, and it is another memo that reinforces some of the other standards and policies that have been released recently, and adds to them in that it identifies that reliability growth must be tracked until requirements are satisfied, and also calls out the need for reliability growth curves that demonstrate the reliability growth. It discusses requiring a test and evaluation strategy to demonstrate reliability, and the need to implement a comprehensive reliability and maintainability program, which again was very similar to ANSI GIA 0009. Finally, the Lifecycle Sustainment Quad Chart from the DoD BCA Guidebook. It gives basically a high-level view of reliability and sustainability activities, and provides high-level visibility of sustainment factors. So it really increases the visibility to key factors that are driving reliability, and provides those to the product support manager and program manager level. If you look through those different policies and requirements, there's a number of common themes. One of them is that you can see there's substantially increased DoD oversight and governance. There was a substantial investment in ANSI GIA 0009. There were over 350 subject matter experts from different industries that validated it, and you can see that sort of activity, in addition to creation of a product support manager position for all ACAT 1 and 2 programs, leads to a much better oversight and governance from a DoD perspective, and improved visibility on reliability and sustainability tracking and metrics. There was a number of scenarios where, or in requirements that called out increased use of reliability growth and reliability growth charts and corrective action processes, and the quad chart that provides the visibility and so on. So there's a number of different aspects of this, of the policies and requirements, indicate need for additional visibility from a program manager and product support manager perspective, so that they can make the correct decisions and identify needs for additional corrective actions to minimize cost while maximizing reliability, availability, and other maintainability metrics. Additionally, the concept of reliability, availability, maintainability, and sustainability as lifecycle activities resonates throughout the policies. There's a number of different items underneath there that point to that. Incorporating customer needs into the reliability program plan is one of them. So making sure those needs are captured and they're included in the program plan and tested against. Implementing a comprehensive reliability growth plan to verify that those customer needs are met. Improved design phase analysis and analyses that accomplish increased reliability and reduce the logistics footprint while shortening affordability. And this is a key aspect of this that ties back to RAMC, reliability, availability, maintainability, and cost, where there's different trade-offs that need to be understood between the performance and suitability of the product and the cost of the product of the system. Test and evaluation to demonstrate reliability and track reliability growth, and monitor fielded product performance. And again, there's a mention of the corrective action processes and in-field reliability growth processes, and then communicating corrective actions and tracking the growth there as well. So a number of common themes here that point to life cycle activities, global visibility, and increased oversight and governance. And with that overview, I'll turn this over to Lowell.
Yeah, thanks, Dan. My name is Lowell Nilsson. I work for BAE Systems. I work in the Land and Armaments Division. And before I get into the meat of the presentation, let me give you a little background on who we are as a company. Our primary focus is on defense and security. We design, develop, produce, and support major aircraft programs in both the UK and the US, such as the F-35, a range of warships and submarines, armored combat vehicles such as the Bradley, as well as through-life support maintenance, and training for current and future defense systems. As you can see from this chart, we do have both a presence across the United States as well as internationally. This provides us an opportunity to leverage an extensive resource for skills and experience, but it also provides a challenge to maintain consistency of best practices across the company. As far as a lot of coordination, a lot of documentation and communication to make sure that we are adopting what we need to in order to satisfy our customers. All right, in terms of who we are, from a company perspective, Linda Hudson is our president and CEO for the BAE Systems, Inc. We're a top 10 prime contractor for the U.S. Department of Defense. We employ around 40,000 people in the U.S. We're organized into 5 sectors, one of which is land and armaments, which is the sector for which I work. Within land and armaments, we have a department called Logistics Services, and our goal, our function is to be able to provide and deliver equipment and products that are supportable, that are reliable, that are available, maintainable, transportable, and that the soldiers and the sailors have the necessary tech manuals for operation and maintenance of the platforms. Our customer is the men and women in uniform, to make them effective at what they do and to bring them safely home. All right, in order to effectively implement this and make our platforms reliable, we have to obviously address the reliability challenges. And historically, the way this has been done in the past is predictions have been performed during design and development, oftentimes using multiple tools. The result is that some reliability drivers are addressed during design, but a lot are addressed during system-level tests. If you wait until system-level tests to address these drivers, this can increase cost, it can increase the number of test hours, increase the test length, and it becomes ineffective at really optimizing the way we drive in reliability. The results of this approach, as the government has even surveyed, is that a lot of times the requirements aren't being met, requirements that are being levied by the government on the contractors and suppliers. And so what the government has done is they've taken a look to determine, is there a new way of doing things? So what they have adopted is what is called a Ranty case. It's kind of a paradigm shift. They've understood that the way we've done it, the legacy methods, that they haven't really succeeded in the way that they've liked. So what they've tried to emphasize is a little bit of a less emphasis on metrics. They want to move away from handbook predictions and place more emphasis on the methods that are being adopted in order to drive out failures. What they call this Ranty case first originated in the UK in 2003 as the Ministry of Defense standard, with the basic tenets being adopted by the DoD. The intent is for the suppliers to provide what they call progressive assurance in their case for achieving the specified level of reliability. The focus is on initial analysis, such as FNICAs, making sure that those are being executed and adopted. Methodologies such as physics of failure, to include finite element analyses, probabilistic analyses, and other similar types of physics of failure investigation, as well as the reliability enhancement testing, such as HALT and ALT and other similar test methods. All of this, they want the contractor suppliers to focus on, document, and identify how the adoption of those methods will improve reliability. The 0009 standard is a result of this effort. And the government has worked with industry to develop and implement this new paradigm. So from this chart, at the top is the legacy approach, again, with the emphasis on really a late identification of failures with a limit on what you can do for corrective action. If you have a platform or a vehicle that's essentially built, there's a lot of constraints in place in order to redesign something in order to make it more reliable. So with this paradigm shift, the focus is on an early identification of those failures, both component level failures as well as you move through the design paradigm. As you do your integration, there's a greater opportunity to identify those failures and redesign your components, redesign your interfaces, so you can have a more reliable system. What that takes, though, is a better understanding of your data, a better understanding of not only each of your individual products, but how the data relates across basically your enterprise. So when we look at our data, we look at it really at two levels. One level is the systems view. So in this example here, customer requirements drive reliability. They drive the reliability allocations. Reliability analysis drives the maintainability analysis. The system architecture drives the testability model. There's a lot of dependency, a lot of interrelationships between all these products and these data elements. So enterprise tools are critical in order for us to understand and manage these dependencies and give us more of an opportunity to improve our system. Sorry, I flipped that one too quick there. This is a view of both of our business process as well as how our business process relates to the enterprise solution. So this is our second level of data management, and this is within the domain area. So, for example, FMICA is related to fracas and reliability block diagrams, so that, for example, as you're doing your FMICA, you identify your failure modes, you identify your corrective actions, your mitigations and corrective actions. That should result in a test, for example, and then as you execute that test and as you identify your failures, that should get rolled back into your FMICA, which then impacts your predictions because you're improving your reliability. So we've got a business process that understands those relationships, and we need an enterprise solution that can really help us manage that data. So we're working with PTC to leverage their products to better manage not only the reliability data, but how it integrates with maintainability and some of our other key aspects. What this does is help us obviously improve the reliability of our systems, which results in increased customer satisfaction, not only because we're improving the reliability, but we're also better able to demonstrate that we're on track to meeting the requirements that they have levied on us. So we're providing them the progressive assurance as we go through the design and development process, and it really helps us to address our customers' needs. Thank you very much. Back to you, Dan.
Thanks, Lowell. Okay, so Lowell had mentioned how he's using working with PTC and the windshield quality solutions to help support the data model that he just discussed, and wanted to spend some time drilling in some more detail on that, on PTC's solution to some of these challenges and these recent reliability directives that are coming from the DoD. And that solution is called Quality Lifecycle Management. Let's go through a few slides on that aspect of the presentation. So what is Quality Lifecycle Management? Well, as you can see below the puzzle pieces, in most organizations, a number of the different activities are performed as a part of reliability, quality, test. So there'd be RAM-C and RAM-T activities are often broken into a number of disparate systems that might be Excel spreadsheets or other databases. And QLM enables the planning and management of these different activities, so reliability, safety, risk, affordability, and so on throughout the product lifecycle by connecting these different components together into one integrated system. And This next slide shows how that, at a high-level view, what the concept of that connection looks like. So, if you look at the different phases of your of the system development and support, planning, design, test, manufacturing, sustainment, and support, there's different activities, those different pieces of puzzle that would fit in, and those activities be performed inside each one of these different phases. So from a planning perspective, there would be some life cycle cost analysis that may be performed, some early FMEA activities, some allocation work potentially that might be performed earlier in the process. During the design activities, there may be, again, additional risk analyses and some of the FMEAs and corrective actions that Lowell was referring to in his presentation earlier, and so on. So there's different activities to be performed in each one of these different phases. And around the outside of this circle, that's where there's connection points between each one of the different activities that are being performed. So as an example, going from design into test, there would be the ability to generate a test plan that links back to both the customer needs and requirements, as well as high-risk failure mode items that need to be considered, because they've been obviously identified as high-risk failure modes. You may put a corrective action in place, but you also need to put a test in place to ensure that the corrective action was successful. So activities along those lines, so that traceability throughout the product life cycle from that perspective, and then also taking the data back to the center part of this hub, to the quality lifecycle management in the center, and allowing that data to be reused both throughout the current iteration of the system being developed, as well as between generations of this system. So identifying common failure mechanisms and failure rates and so on. So some of the probability aspect of this, as well as some qualitative activities that you could generate and allow you to learn from generation to generation. If you look at the benefits of quality lifecycle management in federal aerospace and defense, you can see that most organizations, traditionally at least, there's siloed processes throughout the product lifecycle. So engineering might be working on a product development activity, and reliability may receive that bill of materials very late in the process. It's a kind of a common situation for that bond to be received late, to then perform reliability predictions and FMEAs relatively late in the product development process, where, like Lowell mentioned, it's difficult to have an impact on the product design and on cost, on affordability analysis and reliability and availability and so on. So this is kind of a traditionally siloed approach here. And the impact from a quality lifecycle management perspective is to connect these dots. So instead of you providing that bill of materials late, allowing that engineering and reliability to participate together early in the process when you're doing program planning. So allowing you to pull forward some of the FMEA activities and the risk analysis, the reliability analysis, sustainability analysis, life cycle cost and affordability analysis earlier in that process. And then also, so integrating those processes early, proactively addressing risks and identifying corrective actions that are closed loop and traceable. Ensuring the product design matches the required and predicted capabilities. So that's toward the, if you look from just the reliability phase alone, there's integrating the changes early in the process, proactively addressing the risks, and ensuring product design matches the predicted capabilities. Those will all be key benefits to quality lifecycle management just in that one section of the overall process. But then also identifying and tracing sustainment needs across the life cycle, optimizing the investment, reducing life cycle support and logistics when you're over in the affordability area, identifying cost of service, replacement, and repair based on some of the early models that were developed, and using that model to identify potentially better cost strategies, from better repair strategies that would reduce cost. And from a product test perspective, tracking test and field data against product requirements, incorporating reliability growth into the test lab, and tracking the bill of materials itself, which can sometimes be a challenge for organizations. So identifying the as-tested bill of materials that's being used in the product test lab, compiling your lessons learned from the testing into a single source of truth, and when you're out in the field with a fielded product, be able to identify the failure mechanisms that are primary drivers for lack of field performance. So again, looking from a reliability growth perspective, doing your Paretos, understanding what the underlying failure mechanisms are that are driving unreliability, and doing the cost analysis, doing a cost analysis to justify changes to those systems, and including that in so that a more affordable, higher reliability approaches evolved even in the post-production support area. And if you look at this from a process perspective, the way that the quality lifecycle management process may be deployed, and again, this is something that there's a number of building blocks here into quality lifecycle management. You saw the puzzle pieces earlier, but in most organizations, you start with your program start here, and from that, you're going to your planning phase. We're going to define your requirements and basically make sure that the requirements are being captured. Per some of the directives we discussed earlier, identifying your project plan, looking at allocations and cost activities, including a number of different modules and functional sets that you can see over here on the right side of that planning phase. Going from planning into design, and 1 second here, please. There we go. Going from the planning phase and feeding that information forward, so the early conceptual decisions that were made to reduce risk and increase reliability availability, feeding those forward into the concept selection and design phase, where effectively more details are being developed, and there's spares modeling that may be generated at this point, and fault tree analysis, and so on, and basically identifying engineering changes at this point in time, or modifications to the design based on risk, on reliability, availability, maintainability, and cost metrics that are driving the decisions. From that concept selection and design, feeding that forward into the test plan, which is, you see DVP there, that stands for Design Verification Plan. So feeding a design verification plan that would allow traceability back to the requirements that were designed in the early planning phases, but also from the FMEAs that were generated that are also tied with some of the quantitative reliability analyses, tracking of those tests and identifying your test results, and generating things like reliability growth or accelerated life test statistical results. Also sending the data from concept selection design into control plans, which are going to be for higher volume products and systems. This would be where you identify your sampling rates, send that information over to manufacturing, and track non-conformances in the manufacturing phase to see if you can feed forward into that process what the plan is, and then track performance afterwards. And then also from a planning perspective, for field support, identifying spares and maintenance plans, and then in the field, using the fracas to track the failure reporting and complaints that are coming back from the field. So basically traceability from planning into concept, and then communication of that data and that knowledge into test, manufacturing, and field support with identified plans, traceable metrics, and as the results get tracked, pulling that information back into performance analysis and feedback. So using a fracas system, doing the training and quantified performance, generating the metrics, it's things that would basically feed that quad chart, MTBFs and cost of operation and so on. And then feeding that knowledge that's gained from the performance analysis and feedback into change management. So again, identifying from Paretos where the highest failure rate items might be, lowest availability, highest cost. You're using that to drive where you're going to make your changes to the system to increase availability and decrease cost. And then storing your best practices and lessons learned. So those failure mechanisms, which are invaluable to closing the loop between how you expect the system to perform and how you actually see it performing, pulling that information back into the beginning of, let's say, a product redesign or a new product design that's of a similar type of product. So it's more of a detailed process view of quality lifecycle management. And then to briefly talk about Windchill Quality Solutions, Windchill Quality Solutions is the name for what used to be known as RELX. RELX was acquired by PTC in June of 2009, but prior to that, the first software release was back in 1986. RELX had an extensive presence throughout aerospace and defense, very well known for RAMS analysis. And corporate standard for a number of different organizations out there. And some of the key capabilities that RELX was developed for were to identify system performance early in the product design process, so you design for reliability activities, identifying cost and performance metrics, and then tracking against that. So planning early, designing for reliability and availability and so on, and then tracking that and managing the changes and managing, the fracas data and so on that would be used to identify need for change throughout that process as well. And it's a little background there, and I'll turn it over to Lori for Q&A.
Thanks, Dan, and thank you, Lowell. At this time, I would like to open the floor for the Q&A session. So please enter your question via the question box that's located under the Q&A menu at the top of your screen. And I will just give a minute or two for people to enter their questions. Okay, we had one pop up. So, is the QLM compliant with the ASD AIA Lifecycle Specification Suite? For example, S1000D, 5000F, 3000M, etc.
QLM is actually a process that includes a number of PTC products. We've discussed there at the end of the slide deck, we discussed RELX and some of the reliability and availability, maintainability, and cost analyses. But also in the PTC suite of tools is a tool called Arbortext that has S1000D compliance and is a tool that's in the same product development system as the Windchill Quality Solutions. So that is is definitely an important part of quality lifecycle management.
Okay. Great. We have another one, actually, and I believe this one might be for Lowell. So the U.S. DoD is focused on RAM-C to identify the optimum balance between performance/sustainability and lifecycle cost that allows for the continuous complex affordability trade-offs between reliability, maintainability, availability, and lifecycle cost. The goal of RAM-C is to identify if the readiness benefits to be achieved are worth the lifecycle cost. How is BAE Systems planning to address this critical mandate?
Yes, good question. I think that's where the 0009 standard really provides a good segue or lead in to address that, because what the 0009 standard allows us to do and actually drives us to do is, as we identify our progressive assurance, as we identify those methodologies, whether it be in the reliability or in other domains such as maintainability, that provides a mechanism by which for each methodology that we select or that we identify, there's an associated cost with that, as well as an associated impact to meet the requirements. So it provides a natural mechanism for us to give something to the program manager in order to perform the necessary trade-offs, so that they can look at, okay, what's the cost for this reliability method and the corresponding impact to the system, as well as the corresponding impact to the life cycle. So again, I think the standards provide a natural means to accomplish that critical trade-off.
Okay, great. Thanks, Lowell. Let's see, another one came in for you. How is the rollout integration coming along at BAE, considering the different products BAE designs, and what is the usage estimate or percentage of PTC tools across each BAE division using such, if you know?
Okay, yeah, we're moving along pretty good in terms of the rollout. What we're doing right now is we're working with PTC on identifying some of the key capabilities that we need up front, such as Samica or Fracas, and those are getting in place now for the new programs that are coming on board. And then what we're also doing is we're looking at our legacy programs on a case-by-case basis to see really what the cost-benefit is of transferring that data or transferring that approach into the tool suite that we're working with on implementing with PTC. So we're definitely moving forward with implementing the new programs. And again, like I said, on the legacy, it's on a case-by-case basis. In terms of across the board, yeah, I probably don't have a good handle on that, especially given that we're one segment of a larger organization. I know there are other sectors that are implementing Relics, the QLM suite, such as our electronic solutions. We're partnering with them and looking at their lessons learned and vice versa. So there's definitely a wide use, which is one of the reasons why we decided to go with the QLM suite to begin with. But as far as percentage, no, I really don't have that offhand.
Okay, and is the government willing to pay for these efforts? That's the question that came in.
That's, again, good question. There's probably two sides to that. One is on some programs they are mandating the 0009 and the adoption of those kinds of practices. So a natural part of that is to support the delivery of those, and there will be a natural means then for the government to pay for the delivery of those products as well as the associated practices that go along with that. At the same time, the government does have an expectation that we have best practices in place in order to support them. So we as suppliers and contractors, it's important to us to satisfy our customers, so we also incur an expense on our side to make sure that we're doing what we can to have best practices in place.
Okay. Now, in regard to the 0009, someone asked, how satisfied was the government in your implementation of the 0009 standard? Since your RAM team previously used and evaluated a number of different competing commercial RAM software packages, what was the key discriminator or discriminators about the Relic software suite that led you to select it as your RAM standard?
Okay. In terms of the government's perception of our execution of the 0009, from the conversations and communications that I had with the government during our last program, which was really the first major effort under 0009. Actually, it was even before it came out. We were really a test case for that. They were very, very happy with what we were doing in order to address the progressive assurance needs. We would have, for example, weekly, sometimes monthly meetings with not only government experts but industry experts to review our practices, our adoption of this RANTI case, of this new paradigm. And the feedback that we always got was that we were executing the way that they had expected, that we were doing the necessary diligence on and performing the initial analysis and utilizing and leveraging the physics of failure that are naturally part of design and development activities. So they were pleased, and we were able to demonstrate the results, that we were able to identify defects early and design them out. In terms of what the key discriminators were for our adoption of the QLM suite, really came down to a few areas. One, like I had indicated earlier, we have a number of other sectors that use the QLM suite already. They already have it in place. They're already looking at not only how to tailor and configure that suite of tools for their business process, but how to integrate it with some of their other tools. And so we're able to leverage some of their lessons learned, and not only internally within BA Systems, but some of our key suppliers on our major programs, they also have adopted the QLM suite. So that provides a natural fit for us to provide a comprehensive product to the customer rather than trying to merge together data from various sources. Also, what was key for me as I participated in the trade study was really the maintainability aspects of the QLM suite was key because of the natural, shall I say, synergy between reliability and maintainability, where maintainability naturally is driven from the reliability data. It's very useful and beneficial to have those products in the same tool suite. So that was also a key factor in our decision.
Okay, great. Our company is currently about to model a complete aircraft in OpSim on a system-by-system basis to monitor impact on aircraft availability through changes in MTBF, MTTR, and sparring TAT. Has this level of modeling been carried out before, and if so, are there existing models that may help us tackle this mammoth task? I think that's for you, Dan.
Right. Actually, there's in the OpSim software, that is something that was actually built for both aircraft systems as well as naval vessels to handle the availability and sparing models, as well as multiple mission phase capabilities. And so we received input and guidance from some of our customers there for a number of different high visibility aircraft programs and naval programs, and in constructing OpSim and in some of our more recent releases of OpSim. So there's some great capability there to handle those spares models, as well as multiple mission phase, where you might have scenarios where certain systems might have a different failure rate from phase to phase. You might have maintenance-only phases you're considering. There might be certain failover activities or dependencies you need to identify for repairability of the system. So, let's say, for instance, if you have an individual block fail, it might cause failure of a number of other blocks in that same group, which might be something that's very useful in radar arrays. The same thing might be true from a repair perspective. So there's some really good capability there to help with those models. If there are any questions after this conference, I'd be happy to help address those specific questions, or you can reach out to your windshield quality solution support team for some help with that. As you can imagine, there are the actual math models and so on are basically hidden behind the scenes inside OpSim. So if we're looking from a model perspective, those models are built into that tool. But from a subsystem level, if you're looking for your subsystems or LRUs or FRUs, for instance, and trying to identify if there's properties there that you can use, then a couple different options are available to you. One of them is that in the reliability prediction and maintainability prediction tools, there's a number of libraries there that allow you to identify expected failure rates and that you might use for those LRUs and FRUs. From a maintainability perspective, there are task libraries you could use to identify expected MTTRs that you'd use in constructing the model. So you've got some libraries of data that are provided out of the box, but then there's also the ability to create your own OpSim specific libraries. So now that you can create things that are like individual block libraries of individual components and their failure and repair properties, as well as cost properties, whatever the case might be there. And for entire block diagrams, you can have nested block diagrams. The system's been constructed in such a way that allows you to nest these complex systems because it's very difficult to trace what's happening if you're trying to do an analysis on one huge sheet of virtual paper, right? So it allows you to nest these down in. You can capture the entire sub-level diagrams and store those and reuse those as well. So there are some out-of-the-box libraries, and then there's also libraries that the user can create to make their lives easier to enable reuse of data, both at an individual upfront failure repair property perspective as well as inside the OpSim block diagramming tool as well.
Okay, very comprehensive answer. Thank you. I think we have time for one more question. So the question is, how would you recommend that I compel my managers and engineers to embrace the quality lifecycle management process?
Okay. If you'd like to, I can start with this, and Lou, I'd like to have your feedback if you have anything to add to this as well, and I'm sure you do. But from a quality lifecycle management perspective, first of all, for customers that are being governed by ANSI GIA 0009, that is actually something that in and of itself might be a very compelling event that would help drive adoption of quality lifecycle management. If you look at ANSI, if you look at 0009, it identifies where you need to capture system engineering, the need to capture upfront requirements, have those traceable in a test, doing your design for reliability activities, you're tracing field performance and doing reliability growth. There's a lot of overlay between 0009 and quality lifecycle management. It's a very close correlation because they're both based on a good scientific approach to making a system high reliability and availability and low cost comparatively. So there's a lot of overlay there. So if you're trying to drive quality lifecycle management and you're governed by 0009, if you need to follow that spec, well, that is something that is required. 0009 is required by the DoD. So that alone might be a compelling event for you to push forward with quality lifecycle management. It can make things a lot easier for you. But also from taking that argument out of the way, in a lot of cases, what makes a lot of sense is to attack, when you're trying to deploy a new process, anytime there's a new when you're trying to make a change like that, it could be a philosophical change for your organization. And so there's a change to the process, there's some training that needs to be involved, there'll be tools that need to be involved to help enable that process. And when you have a change like that, it's great to try to get high-level management buy-in and try to get a champion, because it makes it a lot easier, because there'll be a number of different groups involved. So there'll be people inside PTC that can assist you with the arguments and the benefit analysis to make those arguments. But if controlling things within your specific group, oftentimes if you can take this from a phase perspective, you can say, okay, here's the vision, here's what 0009 wants us to do in combination with DTM 11003 and so on. If you look at all these different pieces we've talked about, you can see what the vision is that's being pushed for, and say, okay, this set of tools or this system enables us to support that vision and what the requirement is, and we can demonstrate a small part of that. If you look at it from a phase perspective, maybe we can demonstrate a small part of that overall vision within our group, but you can see how this actually ties back to this overall vision, which is going to be instrumental for us keeping our DoD customer happy and delivering the results they're looking for. So a couple different things. One of them is the 0009 and these other directives are all requirements, and that alone should help push enable you to help push for a meaningful change. Secondly, there are resources at PTC that can help you with both the process and the benefits analysis and so on. And then lastly, once you have that information, you're helping identify maybe a phase-based approach that allows you to demonstrate results and then basically follow up with that with maybe a more broad spectrum deployment.
Yeah, Dan, this is Wally. I agree with that. And what you said there was key, demonstrating value. As everybody knows, management has a lot of stress. There's a lot of shall I say, stress on the budget. They have a lot of demands, is probably a better way to put it, a lot of demands on the budget on their time. So if you can look for those, as we say, those quick, easy wins, in order to demonstrate that value, it'll provide that compelling argument to management to say, yeah, this will work and we can adopt it. So then you can then, like you said, move forward to the phased approach and continue to increase that. Management is always looking for, the mantra today is continuous improvement, and that is crucial to business. We need to continue to adapt, continue to be flexible, to continue to improve the way we do it. So management is looking for that, but what they want to see is something that will work, something that will actually provide that value that they need in order to satisfy the customer.
Okay, great. And with that, I'd like to conclude today's presentation. I'd like to thank both Dan and Lowell for taking the time to present today. For those who are listening, if you would like more information on quality lifecycle management, you can visit PTC's QLM Resource Center, and you can get there by going to www.ptc.com.